Intensity pattern of capital N slits, part D. Use the result for the electric field amplitude in part C to show that the intensity at an angle theta is I0 sine n phi over 2 over sine phi over 2 squared, where I0 is the maximum intensity for an individual slit. And part E, check this result for n equals 2. Recall that sine 2a is 2 sine a cosine a. Okay. So we have this result from part C. The amplitude is E0 sine n pi over 2 over sine phi over 2. The intensity at that point, at point P, will be proportional to the amplitude of the electric field at that point squared. So it will be E0 squared sine n phi over E0 squared sine n phi over 2 over sine phi over 2, that's the amplitude of the wave from part C, squared. And the maxima in the intensity will occur when we have a path difference of d sine theta equals to integer multiple of wavelengths. That means the phase difference phi should be equal to 2m pi, integer multiples of 2 pi. Now the intensity is, let's say, a proportionality constant c times sine n phi over 2 capital N phi over 2 over sine phi over 2 squared. If n is equal to 1, what would we obtain? Sine phi over 2 over sine phi over 2, that's 1. And n equals 1 means we have a single slit. The intensity would be equal to C, which is basically I0. So that's what I'm going to call I0. So then the intensity of a single slit that I have called I0 is basically the prefactor of sine n phi over 2 over sine phi over 2 squared in the intensity distribution. I0 times sine n phi over 2 over sine phi over 2 parentheses squared. So that is the intensity pattern. Okay, let's check the maxima. The maxima occur at pi is equal to 2m pi, d sine theta equals to m lambda. So limit as phi goes to 2m pi, what is this number? Sine n phi over 2 over sine phi over 2. So we will obtain an integer multiple of pi both on top and at the bottom, so that will give us a 0 over 0. If you use L'Hopital's rule, we will obtain limit as phi goes to 2m pi, the derivative of the top divided by the derivative of the bottom, capital N over 2 cosine capital N phi over 2 and 1 over 2 sine 1 over 2 cosine phi over 2. 1 over 2's will cancel. Cosine m pi divided by cosine m pi, cosine m n pi divided by cosine m pi. that's going to be equal to 1 divided by 1. So this will become capital N. So let's see here, we're obtaining cosine capital M n pi divided by cosine m pi, right? So this is either plus 1 or minus 1. So basically we will obtain plus or minus n here depending on the values. But as for the intensity, the maximum intensity that we will obtain will become, because it's a sine n phi over 2 over sine phi over 2 squared, plus or minus doesn't matter here, this will become capital N squared. Capital N squared times I0. So indeed we will find that the maximum intensity is capital N squared I0. The intensity is I0 times sine n phi over 2 over sine phi over 2 parentheses squared, where I0 is the single slit maximum intensity. Okay. Now in part E, we want to check this for capital N equals 2. Capital N equals 2 will give us an intensity pattern I0 sine phi divided by sine phi over 2 parentheses squared. So we have substituted N equals 2 here, so we obtain 2's cancel, sine phi over 2 squared. Now this is I0 times sine phi can be written as 2 sine phi over 2 cosine phi over 2, and here we have sine phi over 2 squared. Sine phi over 2's will cancel, and we will obtain 4I0 cosine square phi over 2. So that means the intensity that we obtain here is I max times cosine square phi over 2, where I max is 2 square I0. And that's exactly the result that we know from Young's double slit experiment intensity distribution. So here I have looked at the intensity at point P by looking at the magnitude of the electric field at point P squared, because it's proportional to that. And for n equals 1, I call the maximum intensity I0. The maximum intensity is basically this constant C here, which occurs when phi is equal to 2m pi. So this gives me sine of 2m pi multiplied with, so pi over 2 gives me m pi n divided by sine m pi. But we have shown that as we go to this limit, as phi goes to 2m pi over phi goes to 2m pi, sine n phi over 2 over sine phi over 2, 0 over 0 is actually going to be either plus n or minus n. So that's going to be the maximum. So we will find that for n is equal to 1, that squared will give us 1. So this intensity is maximum I0 for the single slit. And for n number of slits, this ratio is plus or minus n, its squared is capital N squared. So capital N squared I0 is the maximum intensity. For n equals 2, we obtain sine n phi over 2 is sine phi, which is 2 sine phi over 2 cosine phi over 2. Sine phi over 2 is cancel. We obtain 4 times I0, which is 2 squared times I0. So it's maximum intensity times cosine square phi over 2.